This is AP Calculus Lesson 9-1, a note that we only have 3 lessons in this entire unit, so it goes very, very fast. All right, so by the way, everything that we're doing is dealing with Riemann sums and average values. So Riemann sums, there's a graphical way to do it, there is an equation way to do it. The equation way to do it is usually associated with BC calculus. We're doing AB calculus. So we will eventually talk about it though. All right, so tabular rates and integrals. What information is given? And this is the difference between finite and infinite. So when I'm given a table, what am I given? Is it finite or infinite?
Finite.
Finite, yeah, it's not infinite. Obviously, I don't know what happens at time equals 5 or at time equals 9. There's a bunch of gaps in our knowledge. So we're dealing with finite when we have a table. All right, so let's go ahead and graph these points on our graph. So where are these going to be? 0, 0, that's pretty easy. That's down here. We have 417, so that's right about there. And we'll label this 417. And then it goes to 10, 135. So 10, 135 is right about there. That's 10, 135. And then we go to 13, 189. So 13, 189. Ooh, yeah, so I'm running into myself. But it should be right about there. So we'll say that that point right there is 13, 189. And 20, 202.
Shouldn't 189 be above? Oh, wait.
And what do we got? 27, 342. 27 is right about there. 342 is all the way up here. So that's 27, 342. All right. So the point that I'm trying to make here is that there are large gaps in our knowledge. We don't know what's happening.
Do we have to draw a line?
So the whole point is you can't draw a line because, and don't copy this down in your notes, but what could be happening is you have something weird like this. I don't know, it goes through those points, but we don't know what happens in between those points. It could be doing weird things. It could be doing a really general average like you would normally picture. We don't know exactly what's happening in between those points. It's the problem with finite data. What does infinite data look like?
That's when we know.
That's when we know it's a line. Yeah, so if it gives us a line, a graph of a line, then that's infinite data. Can you ever give a table of infinite data?
Unless you just do 1, 2, 3. Oh wait,
because then there's always the desk.
Yeah.
That's like trippy.
So can you?
Yeah, you
I
could
know.
technically, but it would take forever.
If it was an infinitely long table, then we can have an infinitely...
And you would spend an infinite amount of time making it.
Right, so the general idea is when you have a table, you're probably in the finite realm, right?
Wait, is there a way you could do that? Because like there's always more decimals you could go to.
Yeah,
Right?
like 1.3112112. Like you have
Yeah.
to like, go even further.
Yeah, and but then even more than that too. Like
Exactly, yeah. So there isn't really a way to make a table. It would be infinitely long.
Oh my God, Rosalie. Let's see it.
All right. So, what do I need to talk about? I think that picture kind of demonstrates that there are gaps in our knowledge. Let's move on to the next part. So this part is
That's all we're getting from that? It's like you can't draw a line.
Yes. So estimating. This is really approximating a rate. All right, so let's do a little bit of review here off to the side. Do we remember the general formula for finding this general slope? It's all the way back from many units ago. Say that again, Sophia?
Y equals mx plus b.
Okay, that's slope-intercept form. How do we find just slope? The f prime of any point between a and b.
So like f of b minus f of a.
That's the one I'm looking for. Yep. That's the concept that we're talking about. Well, I guess this is really, it's approximately, because this is estimating. It's not exactly. So we're going to use our table from our previous slide to answer some questions here. All right, so I want to know what g prime of 7 is. I want to find the slope at time equals 7. So at 7 days, and notice that there is no 7 days between 4 and 10, I need to approximate what the slope is going to be. So what am I going to do? Hint, hint, hint.
F of B minus F of A over B minus A.
Yeah, what are our A and B going to be?
The first and the last.
So 0 and 27?
Well, I don't know. 0
Just a
and
guess.
7.
Not 0 and 7, because we don't have value for 7. We can only use data that's given to us.
So 0 and 27.
0 and 27 is too large of an interval. Remember, I'm looking for g of 7.
0 to 10.
Not 0. So if 7 is right here, we want to look at this point
Oh,
and
4
this
to
point.
10.
Yeah, so 4 to 10.
Oh.
So you choose the points closest to you. So we'll take g of, and it would be g of 4 and g of 10, but I'm going to do it backwards because it's going to be, I know g of 10 is larger. So g of 10, just like we have our b first. So g of 10 minus g of 4, all divided by 10 minus 4. Which is about what? So what is g of 10?
Isn't it 135?
It is 135. 135 minus g of 4, which is 117, all divided by 6. So what is that about? And this is where we use calculators. 135 minus 117, 18. Oh, 18 divided by 6. 3. And what are our units here?
Maybe guests per day or.
Yeah, guests per day, people per day, whatever you want to do. I'm going to go with people per day, because I know how to abbreviate people. Either one would be correct. Let's try another one. Let's try the approximate slope at time equals 25 days. What am I going to do? And this is not equal to, it's approximately equal to 25 days. So again, I'm looking at these two values, 27 and 20. So go ahead and do it on your own. You can check on the board to see if you're doing it correct.
Wait, what was the date?
The 25th.
So what happens if g of 20 is bigger? Do we put it first then, or do we still put g of 20?
So you usually put the bigger one, B, first, and then the smaller one second. But honestly, it doesn't matter as long as you keep them in the same order.
Okay.
Wait, so how come this is an approximation?
Do we use the-
It's an approximation because we don't actually know what's happening at that time. So we say, oh, we can use the closest points to us to get a good idea of what's happening
I-
at that time. Oh, that's not 40. What am I doing? That's 140. All right, did you get the answer that Mr. Sindel got?
Yeah.
Awesome.
I got 20.85.
Ooh, all right, maybe a subtraction problem. 342 minus 202, is that what you got for your numerator? All right.
What's that number?
I thought this was gonna be like super hard, but I feel like it's easy.
It's pretty straightforward so far, yeah.
Is the homework gonna be like totally different?
The homework is going to be very similar. All right, so on to the next part.
Is this our last slide?
This is our last slide, yeah. And it's called Evaluating an Integral. It is one other way to find information from limited data. So let's look at this one. Let's say evaluate the integral between 0 and 13 of g prime of t dt.
Oh yeah, like
So what is this asking for? The integral between 0 and 13 of g prime of t.
So how much is the slope changing between 0 and 13 days?
Be careful. I mean, you're kind of correct, but let's be more specific to the problem. You have guests entering something at a certain number of days.
So how much the guests are changing between the days 0 and 13?
Yeah, so the units is guests, right? Yeah, total number of guests. The total change in number of guests between 0 and 13. So this actually evaluates to, when I take the integral of g prime of t, this is using our fundamental theorem of calculus, that turns back into g of t. And that's evaluated between 0 and 13. And again, that thing, now that I'm subbing in 13 and 0, that's going to be g of 13 minus g of 0. So there is a way to go backwards when it's asking for this type of question,
oh.
because we know that the antiderivative of g prime is just g, and then we evaluate from our bounds. So g of 13 minus g of 0. So g of 13 is 189 minus g of 0, which is 0.
Wait, isn't it 189?
It is, yeah.
Oh, I thought you said 189 minus 0, which is 0.
I-
Oh, you said G of 0.
G of 0. Yeah.
People per day again?
Oh yeah, so what are our units here? People per day? People, what are we doing?
People. Yeah,
Why is it just people?
because it's not G of prime anymore.
So that's the general idea. G prime is the rate, and this one is just people. People. All right, so I want to also write this, and this is kind of what Sophia and I were talking about before. So integral from a to b, so for some bounds of g prime of t, this means, or I guess we need a dt in there too. This means the total change in guests. Okay, I cannot spell. Total change in guests. Measured in people. From A to B days. All right, I want to reiterate too. When you're given a table, the best you can do is to approximate. That's why we're doing this approximately equal to. You can approximate it in a few ways. We talked about just finding the derivative, finding the total change in guests. Make sure we know both of those things for the homework. All right, summaries.